Here we have a data set x, which is called independent variable, and y dependent variable. Independent variable is represented on the x-axis and dependent variable on the y-axis. So if we calculate the mean of x, which is 3 here, so this is the mean line of x, and the mean of y is 4, so this is the mean line of y. Both lines intersect at this point, which is 3, 4. 3, 4. And we have marked this point where both mean lines intersect each other. And the coordinate of this point is 3, 4. Next, we will calculate the gap between the original data, which are represented by these bubbles, and from the mean value of x. So this is called deviation. Deviation of x value from the mean of x. So the x value of this bubble is 1, and the mean of x is 3. So 1 minus 3 is minus 2. And here the x value of this bubble is 2, and the mean is 3. So 2 minus 3 is minus 1. So likewise, we have calculated the deviation of other data point in those values in this column, which is x minus x bar. X is the x value of this bubble, and x bar is the mean value of x. In a similar way, we have calculated y minus y bar, that is the deviation of y value of each data point from the average of y. The y value of this data point is 2, and the average of y is 4, so 2 minus 4 is minus 2. And the y value of this data point is 4, and the average is also 4, so 4 minus 4 is 0. And the y value of this is 5, and average is 4, so 5 minus 4 is 1. Similarly, the deviation of this point is 0 and 1 for this data point. Now we have plugged in these differences in this column. Here we are going to calculate the linear regression line. Regression line is a straight line, and we know the formula of finding the straight line is y is equal to mx plus c. Just switch these two terms, so it can also become c plus mx. In statistics, we normally write it like this: y cap is equal to b naught plus b1 x. Here b naught is c, and this is called y-intercept, and b1 is m, which is also called slope of the straight line. And this is the formula of b1. Now we will first calculate b1, and this is the formula. If you just look at the formula, we need in the numerator this and in the denominator this. So to calculate x minus x bar whole square, so we will create another column, x minus x bar whole square. So we will square up this column. So minus 2 square is 4, minus 1 square is 1, like this. And in the numerator we have to multiply this column with this column, so we will get this column. So minus 2 into minus 2 is plus 4, minus 1 into 0 is 0, and likewise. The symbol this, which is called summation, it is basically sum of the column. So sum of this column, and here sum of this column. So sum of this column is 10, and the sum of this column is 6. So now we are going to plug in these values in this formula, which will give us b1, that is slope of the regression line. So the slope of the regression line is 6 over 10, which is 0.6. Now we will put this 0.6 here, and the equation will become like this. As we know that the regression line always passes through the average of the data. So as we know that this green bubble is the mean or average of the data. So regression line must pass through this point. As this point lies on the regression line, so we can put the coordinate of this point into this equation. The coordinate of this average or mean point is 3, 4. So we will put this 4 in y and 3 in x. And after doing little mathematics, so this will become 0.6 into 3, 1.8, and we will bring this 1.8 on the other side. It will become minus 1.8, and 4 minus 1.8 is 2.2. Therefore, B0 is 2.2. And now we will put this B0, which is y-intercept, into this equation. So this equation will become this y cap is equal to 2.2 plus 0.6x. As this is y-intercept, and on the y-intercept, what does y-intercept mean? It is a point which lies on the y-axis. So this point will be on the y-axis. On the y-axis, x is 0. So the coordinate of this y-intercept will be 0, 2.2. Now we have second point. So let's plot this second point, and this is the second point, which is y-intercept. We have plotted over here, and now we have 2 points. One is this, which is the average of the data, and the second is y-intercept. Now we can easily draw a regression line by joining these 2 points, and this is the regression line. Hence we have calculated and we have also drawn the accurate linear regression line using this data.